Hello friends, welcome to CEC Live Lectures. I am Dr. Pavitra Bharadwaj. I am teaching in Delhi University College as in the Department of Computer Science. So we have been discussing a lot about different topics about computer science which can be useful for undergraduate students of Indian universities who are taking courses in computer applications, information technology or computer science. So today in the same series and in the same chain of lectures, we will be starting our new series on computer networks today. So in this series, we will be talking about computer networks, what are networks, what is the architecture of networks, and what are the different protocols and the different aspects which relate or which are relevant to students of computer science who want to know more about computer networks. This series is going to be of interest even to the students who do not have computer science as their major discipline, because the level will be an introductory level of the lectures. So without further ado, let's start with today's topic, that is computer networks. So let us, first when we talk about network, right? So whatever a network may mean, it may mean a network of roads, it may mean a network of railways, or it may mean a network of computers. Basic purpose of a network is communication or sharing of goods or sharing of thoughts or sharing of ideas or communicating or commuting between two places or between two points. So the same way computer networks also, they serve the primary purpose of information and data sharing between the different devices on a network, right? So if we look at data communication, right, so or sometimes we see the term telecommunication is also used. So basically it means communication which is happening at a distance, right? So we all understand, in so many lectures we've heard about difference between data and information, right? So when you are talking about data, it is basically the facts, right? And we have information which is the process data, right? So information which is presented in a form which is agreed by the two parties, okay, which is agreed by the different stakeholders. Whoever want to communicate, they must have a consensus on what form of data or on what form of information they are going to work, they are going to communicate, right? So this data basically is converted into a form which is agreed upon by the parties, and then that information or that data is shared between them. So basically we can say that when we are talking about data communication, it is the exchange of data between two devices, right? And when we say it is a computer network, then definitely there has to be a transmission medium, right? So data communication is a term which is commonly and predominantly used in terms of computer networks and communication between two computers, right? So we need to have a clarity on what are the basic premises or what are the basic stakeholders when you talk about a communication system, right? So let us take an example of a simple communication system, maybe a verbal communication system, right? For example, when a student is communicating to his or her students, a teacher is communicating with his or her students in a classroom, right? So most of the time the teacher becomes the sender of the information and the students are the receiver of the information, right? Predominantly during the lecture it is like this, right? And then the teacher is giving some material or is sharing some thoughts or is giving a lecture or is taking up a discussion. So there has to be a message to it, right? And the teacher may use different mediums for communication like voice, audio, right? So most of the time teachers speak, so that is audio is the medium, or they may use text when they are using the board to show, to write something, or they can use some multimedia, they can use audio, video, different media of can be used for sharing the message or sharing the information. And definitely there is some agreed language on which a communication occurs, right? So for example, before a class starts, it is agreed, or before the students even take admission, they know that what will be the medium of instruction, what will be the language that will be used in this particular institution, right? So the same components form the components of any communication system, right? So there has to be a sender of information, there has to be a receiver, there has to be a medium, there has to be some message, and there has to be some protocol. So protocol basically are the rules which govern the communication system. So we understand that protocols can be, what is the mode of information exchange, how the information is going to be exchanged, what is the language, okay, what are the basic formats in which the communication has to be initiated, how the communication will terminate. So all these things become a part of your communication system. So when you are talking about computer communication, then also we will see that there is one device which works as a sender, there is another device which works as the receiver, then there is a particular medium on which the communication is occurring. So that could be a cable, that could be an optical fiber, okay, that could be a wireless transmission medium. So different mediums can be used to join the different devices, to connect the different devices, and then there is the message or the content or the data actually which is going to be shared, and then there are some protocols which we will study. What are the different protocols which work when computers or devices are communicating with each other? So we must understand that this is the main, the main architecture of any communication system, whether it is a computer communication or it is a human communication system, right? Now, another important aspect to be dealt with or to be seen here is that when the data is flowing from a sender to a receiver, so the data flow can be in multiple phases or it can be in multiple directions, right? So there can be different modes in which communication is occurring. So there are three primary modes which we talk about when we are talking about data flow. So the communication could be a simplex communication. For example, when one device or one node or one computer acts as the sender and the other always acts as the receiver. So their roles are definite and their roles are not going to change. So there is unidirectional flow of data all the time, right? So in this case, the communication mode is known as the simplex mode of communication. So one common example of simplex mode of communication could be how the processor is sending the data to the monitor, right? So that is because monitor is the output unit, and how the data is going to the monitor. It is always like that, right? In our general surroundings also, we find that simplex communication can be seen in case of television, in case of radios, right? So our device, the device which the user has in his hand, is always a receiver, and the transmission station or the TV station or the radio station, they are always sending the device. The direction of the data flow can never be changed. Another set of another type of data flow mode could be half duplex mode. Half duplex means that one device will send the data, the other device will receive the data, right, but only in a particular time. So the devices, they can change their state. So the sender can become the receiver can become the sender, but at one point of time only one device will send the data and the other will receive. Right, so it is bidirectional flow of data, but it depends upon the time unit. So only one device will have the control over the transmission channel, right? So the most common example of half duplex communication is in case of your walkie-talkie, right? In the wireless walkie-talkie sets, one person only speaks. When the one device stops sending the data, only then the second device can start sending the data. So this type of communication is known as half duplex communication. And then of course we have the full duplex communication, in which both the stations or both the devices can send and receive the data at the same time. So all the data flows in both the directions at all times, right. So all the computer communication, like when our computer is connected to any network, that time the computer is sending as well as receiving the data simultaneously. So that communication is known as full duplex communication. When we are using the mobile phone to communicate with some other person, then that communication is also full duplex, because both the entities can send as well as receive the data at given point of time. So this is about data flow modes, or the different modes in which data can flow on a network. So we have simplex, we have half duplex, and of course we have the full duplex mode of communication. So now we understand that what is data communication system, what are the components of a data communication system, and generally what are the modes in which data exchange can take place over a network, right. So it is the right time now to actually define what a network is. So when we are talking about a computer network, we mean that it is a set of devices. Now generally, when we talk in the network parlance, we will say the devices, we will refer them as nodes. And also please note that we are not using the word computer, but we are using the word device, because any device can work which is capable of sending and receiving data which is generated by the other device is known as a node. So a printer can also be a device, because a printer is also sending a data on to the other devices, right. So it is not just computer, any device which is capable of sending and receiving data is known as a node, right. So and the link through which the data is being sent, it could be a cable, it could be air, it could be optical fiber, it could be infrared signals, it could be radio waves, it could be any medium which is used for carrying the signal information. So in a network, we are saying that there are some devices which we call as nodes. All nodes are capable of sending and receiving the signals, and these nodes are connected through some links which could be either fiber or cable or the other medium which are there, right. So now if you want to look at a network, right, so there are certain criteria on which networks need to be studied, networks need to be evaluated, right. So one very important aspect is the performance of the network. How do you determine the performance of a network? So first thing is, it depends upon the network's elements, right. So what are the devices which are working on a network, what are the links or what are the media which are connecting the devices? These will all determine the performance of the network. We understand that there are some transmission medium like the simple wire, it will be less efficient in transmitting data than an optical fiber, right. So or satellite channels, right. So we know that different elements of the network, different components of the network system, they will be determining the performance, overall performance of a network, right. Then we also need to see the performance in terms of delay and throughput. So what is throughput? Throughput means how much amount of data is transmitted from one node to the other in a given amount of time, right. And the delay means that when the data is sent from one node to the other, so what is the intermittent time which is lagging, what is the lag between the sending of the signal and receiving of the signal. So the performance of a network can be measured in terms of delay and in terms of throughput. So definitely a network which has got the minimum delay and the maximum throughput will be considered as a better network than the other way round, right. Next criteria which is very important to determine the network, or to ascertain, or to to look at a network, is its reliability, right. So how often does the network components fail? What is the rate of failure is very important. Then network reliability is also measured in terms of availability or robustness. Robustness means that how well connected the network is, right. So if one node fails, still if the network is able to work, then the network is considered to be a robust network. So availability means that the network should have minimum downtime, it should be available most of the time. So reliability is another very important factor when you want to evaluate the performance or when you want to evaluate a particular given network. Then security is another very important aspect when you want to look at a network. So whether the data is protected against corruption or loss due to errors or due to any malicious user. So we understand that when data is being transmitted from one node to the other on a network, then the data can get corrupted. This could happen due to two reasons, mainly because the errors can creep in because of the transmission media, because of the environmental noise which is surrounding the media, or because of the very nature of the media, because of the heat which is generated. There can be multiple reasons which can get errors infested into your data. Or on a network there are some malicious softwares like viruses, worms, Trojan horses and so many other malicious softwares are there which can also be intentionally inserted into your data and the data could be corrupted. So a network is considered as a secure network if the data loss is minimum and the data is reaching, the integration of the data is the primary responsibility, right. So these are the few factors which are kept in mind when we talk about any network for that matter, right. So if you look at the physical structures now, when we are talking about a network, we definitely have to look at the tangible aspects of the network, right. So what are the tangible aspects or what are the physical structures which will comprise your network? So when you are looking at that, you need to understand how the network has been created. What are the types of connections which exist between the the different nodes on a computer or on a network? So there can be a point to point connection, like there can be single transmitter and receiver, or there can be multi-point connections. That means that multiple recipients can be there for a single transmission. So different types of connections can be there, and also in another important attribute of a network is the physical topology of the network. When we talk about physical topology, we understand that how the devices are connected to other devices. What is the layout of the network? What is the connections between the different networks, and also the type of transmission which will occur, whether it is a unicast, it is a multicast, or it is a broadcast. So when we say it is a unicast transmission, we understand that one device or one node will be able to send data to only a single node. So it is point to point connection. Multicast means that one particular node can send the message to more than one node at the same time, and broadcast means that one message can be sent to all the nodes which are present in the particular network. So there can be multiple ways in which the transmission can happen. So these are some of the physical structures which determine. So when you are talking about a network and when you are looking at the physical structures of the network, a very important aspect to consider is the topology of the network. So when we call, what is topology? Basically it is nothing but the layout of the devices on a network, how the devices are physically laid out to form the network, right. So definitely when you are saying that it is a network, so it will have more than one devices, and these devices will be connected to a link, and there can be two or more links which will form a particular topology. So topology is basically the tangible or the physical characteristic of your network, how the different devices are arranged. So topology is the geometric representation of the relationship of all the links and the linked devices, right, to one another. So we will see that there are four basic types of topologies, that is the mesh, star, bus and ring, and there is another very important type of topology which is called the hybrid topology. So hybrid topology is another important type of topology, but it is considered along with the other four topologies because it is made up of one of those 4 topologies only. So, when you say topology, you mean how the devices are physically laid in the network and what are the connections or what are the links which are present in that particular, between those particular devices in a particular network, right. So, the first topology that we see is a mesh topology. So, here it is very evident that every device is connected to every other device on the network through a dedicated link. So, for every device there is a dedicated link to every other device on the network. So, this is a very robust architecture, as we can see, because there will be 100% availability as there is a dedicated link from every device to every other device. So, the downtime, there is no question of a downtime in this type of network, right. So, this in this case, the link or the traffic will be carried by that particular link. But one very important factor is that the number of links between the two devices will be very high, right, because every node is connected to every other node on the network. So, therefore, it is easy to calculate that if you have n nodes in a particular network, then every node has to have n minus 1 connections, right. So, you will have n into n minus 1 upon 2 physical links. Why upon 2? Because one node is connected to all the other nodes. So, therefore, the total number of connections becomes 1 less. So, therefore, the total number of connections will be n into n minus 1 in a mesh topology, right. And therefore, in order to accommodate that many links, every device will be required to have the n minus 1 input output ports which will be connected to the other stations. So, say for example, if you have a network which has got 20 computers, so every computer is to be connected to 19 other computers, right. So, therefore, every computer also needs to have 19 IO ports. So, all in all, this becomes a very cumbersome and a very complicated architecture, and at the same time it is also not cost effective, because you will need so much of wiring also around it. But definitely it has a few advantages, like because there is a dedicated link, so there will be no problem of traffic, there will be no problem of network congestion here, okay. And even if one link becomes unusable, then other links will be there, so that the network will always keep running. But this is definitely an expensive solution to the network problem. So, every message here will travel along a dedicated line, and only the intended recipient will see it, right. So, therefore, this network is a very secure and private network, because no message is going to any unauthorized device or any any node which is not supposed to have access to that particular message. So, therefore, this topology has got several advantages, but of course, the main disadvantage which we have discussed is about the cost. The installation and reconnection of this network is very difficult, it is expensive and it is complicated. So, we will be continuing with the topologies. Thank you.